Record. Start.
Hi there, we are Team Dev Rookies, a group of 3 developers from Pimpri Chinchwad College of Engineering, Pune. Today, I, Sugam Phirke,
I, Akanksha Kulkarni,
And I, Bhushan Javalgekar.
are excited to present our project Bookopia, a library management system. Librarians today face numerous challenges in managing students, books, and book lending activities. It's time consuming and prone to errors. That's where software like Bookopia comes in. Bookopia is a comprehensive solution built using Munstack coupled with other cloud storage technologies like Cloudinary and Multo. It allows librarians to efficiently create, update, and delete students and library books. It also offers intuitive user experience. Its modern design, clean layout, and interactive elements make it easy to navigate and use. Also, the entire database resides safely within the MongoDB Atlas clusters, ensuring data persistency. We followed various UX design principles, incorporating color theory and interactive design concepts. Bookopia is not just functional, but it's visually engaging too. Overall, Bookopia is an exemplary web project that seamlessly combines advanced technologies, superior coding practices, and captivating design aesthetics to build a library management system. Now, we shall take a look at front-end architecture of the project. The front end consists of 3 pages. The main page is the home page, and the other 2 sub-pages are the students page and the books page. Both the students page and the books page contain header, carousel cards, which lists out all the students or the books, and at last the footer. Header consists of a logo that also acts as a back button, a search bar, and a add button to add students or books. Now we shall take a look at backend architecture. The backend consists of configuration of third-party cloud storage tools like Cloudinary and Multo to store the student profile pictures and book images. The database consists of controllers and general schemas for the collections in MongoDB clusters. It also consists of route configurations for book data, student data, and Cloudinary data. At last, the database architecture. It consists of 2 collections, namely student details and book details. In the database cluster, which is running on the AWS server AP Southeast 2, the student details consists of general student information like ID, name, email, mobile, profile picture. Whereas the book details collection consists of general book information like book ID, title, author name, description, and book image.
So,
Start.
hello everyone. I am Bhushan, and I will be discussing some of the remarkable code base and operational features that we have implemented in our library management system, Bookopia. These features contribute to functionality, performance, and user experience. Let's explore them briefly. So, first one is 5 to 1 SaaS architecture. Our code follows the organized and modular 5 to 1 SaaS architecture, ensuring a clean and scalable code base. Next one is BEM model. We utilize the BEM, that is block element modifier model, for clear and consistent class naming conventions, enhancing code readability. Then next one is fluid float layouts and flexbox. Wikipedia's construction is based on fluid float layouts and flexbox, allowing for seamless adaptations to different screen sizes and orientations. Responsive units. We incorporate responsive units like percentage and viewport relatives units, ensuring optimal adaptability to various devices. Next one is color theory principles. Adhering to color theory principles, our design creates visually harmonious and engaging experiences, enhancing readability and aesthetics. Then comes browser compatibility. We provide fallback options for browsers that may not support specific styles, ensuring a consistent experience across platforms. NPM ecosystem. Bookopia is built on the NPM ecosystem, leveraging a vast collection of open source packages and libraries for enhanced functionality, reusability, and scalability. Our code base is designed for reusability, maintainability, and scalability, allowing for easy expansion and updates. And last one is desktop first approach. Bookopia is meticulously crafted using a desktop first approach, ensuring full responsiveness across devices. Now we will move towards our operational features. So in addition to and streamline library management, Bookopia comprises two main pages, the students page and the books page, each serving a specific purpose in managing student and book records within the system. On the students page, librarians can easily select a student from a list, granting them access to view and manage individual student records. This allows librarians to update and delete book entries associated with a particular student, ensuring accurate and up-to-date information. Furthermore, to facilitate efficient record retrieval, Bookopia provides a search feature that allows librarians to search for student using any relevant details such as their name, ID, or other identifying information. Similarly, on the books page, librarians can browse through a comprehensive list of books available in the library. They can select a specific book, manage the student assigned to it. This includes updating the student's information or removing the book association if necessary. The search functionality on the books page enables librarians to search for books using relevant details such as the title, author, ISBN, and making it easier to locate specific books within the library's collection. And meanwhile, to ensure data persistence and scalability, all details related to students' books and their associations are stored in the MongoDB Atlas database. This reliable database system ensures that librarians can access and manage records effectively, providing a solid foundation for the library management system. These operational features of Bookopia combined with the code-based features we discussed earlier create a comprehensive and user-friendly library management solution. Now we will look at future scope and plans. While we faced time constraints during the development process, I believe that Bookopia has immense potential for growth and improvement. Looking ahead, there are several key features that can be implemented to enhance Bookopia and provide an even more comprehensive and user-friendly experience. Let's explore these features together. So first and foremost, to ensure a secure and personalized user experience, implementing a reliable login and sign-up authentication system is a must. This will provide each user with a unique identity and safeguard their personal information. Then to create a seamless and error-free user interaction, form validation should be included. This will minimize errors and ensure that all users' input is accurate, resulting in a smooth experience. To prioritize stability and reliability, we must emphasize error handling and testing by addressing any issues or bugs. We can ensure that Bookopia operates seamlessly and delivers a dependable platform for librarians and students alike. As libraries often experience high user traffic, implementing efficient concurrency management is essential. Bookopia should be designed to handle multiple users simultaneously without conflicts or data integrity issues. This will maximize efficiency and productivity for all users. To make Bookopia more interactive and engaging, a book recommendation feature should be included. By analyzing users' preferences and reading history, the system can provide personalized suggestions, enhancing the overall user experience and fostering a love for reading. Next one is discipline and responsibility are vital in library operations. Therefore, a fine or due system should be implemented to encourage timely returns and proper care of library resources. This feature will promote responsible borrowing practices and ensure the availability of materials for all users. Lastly, to safeguard user data and prevent any loss or security breaches, robust security measures and reliable backup systems should be included. This will provide the users with the peace of mind knowing that the information is protected and backup secure. So Bookopia's future is bright and promising. By implementing these features, we can create user-friendly, secure, and efficient library management system. And Bookopia has the potential to revolutionize library operations, making the lives of librarians and students easier and more productive.
Now let's discuss the technological stack which is used in this project. So we have included the MERN stack. MERN stack includes the 4 technologies: MongoDB, ExpressJS, React.js, and Node.js. MongoDB is a NoSQL database which allows us to store unstructured data in the form of document. ExpressJS. ExpressJS is a backend web application framework that offers the tools they need to build and maintain these services. All the backend services nowadays uses ExpressJS. React.js is a library which is used for front-end and UI development. All the web apps mostly are built using React.js. Node.js. Node.js is a cross-platform runtime environment for executing JavaScript outside the browser. So why MERN stack was chosen? So there are many advantages of MERN stack. First is the virtual DOM in the React.js. Since normal DOM changes are expensive, front-end complexity can be handled easily. It is scalable, reliable, as well as we can keep the data persistent in NoSQL data store, which is MongoDB. Only one language is needed to manage all these technologies. There are reusable components in React.js. So all the folder structure can be created by the developer itself. It enhances the developer as well as user experience. It is an open source tech stack, so there's a big community which can help whenever needed. Learning curve is less because only one language needs to be learned. It has fast backend because Node.js is used for processing all the requests. So now you can see all the links present over here. One is the GitHub link. You can view all the code present on the GitHub link. Vite React.js is hosted on the Vercel.com, and the backend, all the web services are hosted on the render.com. The link for the website or web app is also mentioned in the PPT. So now we will go through the code structure. So now you can see here, there are 2 folders, front-end and back-end folder. In front-end folder, you can see all the structure of the code. The SAS is used for styling. All the folders inside SAS are for styling. Roots has all the main pages, which you can see in the view. So in public, we have all the animations included. In CSS, there are some of the stylings, and in components, you can see all the components which we had used throughout all the front end. API has all the global APIs. We can fetch it in any of the component as per the need. If we will go through the backend folder, then the backend folder has Cloudinary info, which is Cloudinary and Multer, which are used for image uploading. The database folder has all the schemas as well as all the connections with the backend MongoDB database. The roots has all the APIs created as per the student or the book section. Now we will check out the website, that is. So this is the library management system, Bookopia. You can manage the students from here. You can see there are total 80 students we had given as the input for managing a large amount of students. You can add new student from here, and even you have to add the image of that student. You can search for any student over here. You can search by PRN, you can search by mobile, you can search by Gmail ID or name. It's your choice. You can even delete any student. You can update the student data from this section. You can add a new book over here, whichever the student has not yet issued. You can add the book and you will see the change over here. The new book has been added. Even you can mark it as returned. So all these functionalities are also included in the books page. So you can see here the books page. The same functionalities are added over here. You can search for any book. You can add new book, or you can update the book details over here. Here you can see the students list who has taken or chosen this book. You can even delete the list of students from here and update it for adding new student. You just need to input the student ID over here, or you can select among any of the students. So these are all the functionalities of our Bookopia. This can be improved a lot later. So we are yet trying to improve it. Thank you.
Bookopia was developed as a part of AFourathon Hackathon 3.0. We, the dev rookies, are proud to have fulfilled all the problem statements within the hackathon time limit. We put our hearts out and soul into creating Bookopia, and we are confident it will make a positive impact. Thank you for being with us and lending us your valuable time.